Good day everyone. My topic is the Doppler effect for electromagnetic waves. Coined Doppler effect. Christian Doppler, born November 29, 1803, Salzburg, Austria. Dead March 17, 1853. Austrian physicist who first described how the observed frequency of light and sound waves is affected by the relative motion of the source and the detector. This phenomenon became known as the Doppler effect. What is the Doppler effect for electromagnetic waves? Doppler effect for electromagnetic waves is the change in the observer frequency of an electromagnetic with the relative motion of the source and observer. Laser Doppler anemometry has developed different configurations. Doppler effect for electromagnetic waves. One of the most important is the differential Doppler for fringe, which concern the interference fringe to two laser beams suspended particles, transported by the air movement across the dark and light fringe pattern. Determine the frequency of electric signals that are then proceed to compute the airspace. The velocity of the suspended particles causes a Doppler shift is the frequency of light that is scattered, and this is measured with a photodetector. In a relatively clean atmosphere, instruments need the introduction of tracer particles in the air trains. The main advantages are the direct method of measuring velocity, leaving the flow and undisturbed, very small sensing volume. Example cube of 0.2. Very high frequency. Example MHz response and used for extremely low airspeed. This system is expensive and is more susceptible for scientific research than routine measurement. Doppler effect formula. Electromagnetic waves do not need a medium. The Doppler effect for electromagnetic waves is simply a relative velocity phenomenon. The shift in frequency observed by an observer depends only on relative velocity between the source and the observer. If the source emits electromagnetic waves that have a frequency f, the observed frequency f is given by. This is the formula. F equals f, open parenthesis 1 plus v equals c, close parenthesis. Doppler effect formula, where v is the magnitude of the relative velocity between the source and the observer. As with the Doppler effect for sound, we use the top plus sign with the source and observer are moving toward one another, and the bottom minus sign when the source and the observer are moving farther apart. Exploring Doppler effect for electromagnetic waves. A catch a speeder. A, a police officer is the stationary police car aims a radar gun at the truck traveling directly toward a police car. The frequency of the radar gun is 10.525 GHz, open parenthesis 10.525 times 109 Hz, close parenthesis. and the frequency of the waves reflecting from the track and returning to the rudder gun is shifted from the emitted by frequency by 1600 Hz. If the speed limit on the road is 60 kilometers, should the officer pull the truck over, give the driver a ticket. Let's work through the problem to decide. Step 1. And the frequency of waves coming back to the rudder gun higher or lower than frequency of the emitted waves. The relative velocity of the two vehicles bring them closer, which effectively lowers the wavelength of the waves, corresponding to higher frequency. Step 2. If the truck is traveling at a speed velocity, write an expansion for f, the frequency of the waves received by the truck. To do this, we can simply apply equation 22.6, where f is the emitted frequency. We use the plus sign in the equation because the truck is moving toward the police car. Step 3. Write an expression for f, the frequency of the waves that are picked by the rudder gun. After reflecting from the truck, your expression should be a terms of f rather than f. We apply equation 22.6 again and use the result from the step 2. Where f is the emitted frequency, again, we use the plus sign in the equation because the truck is moving toward the police car. F equals F plus 1 plus V equals C equals F plus V equals C squared. Exploring Step 4. Step 4. Solve the speed of the truck and decide whether the truck driver should get a speeding ticket. Expanding the bracket in the expression from step 3 gives the speed of light is order of magnitude large than the speed of the truck. So V2 and C2 will be so much the smaller than V and C that the V2 and C2 terms can be neglected. Writing the expression in terms of the known frequency shift 1600 Hz allows us to solve for the speed of the truck. Converting the speed of kilometer gives a speed of 22.8 times 0.001 times 3,600 equals 82 kilometers. This is well over the speed limit. So the driver should certainly get a speeding ticket. Exploring Doppler effect for electromagnetic waves. F equals F1 plus 2V equals C plus V2 equals C2 equals F1 plus 2V equals C.